Thank you for joining this presentation from Science Invents, Missions That Matter. I'm Joseph Firmage, Chief Executive Officer. Let's begin. Project Hoover is the code name for Science Invent's first major space mission, 20 years in the making. It's involved hundreds, if not thousands, of people worldwide for 20 years, and it is a privilege to present this to you today in everyone's behalf. Please enjoy the further presentation of our first space mission. I'm introducing today Mission Vacuum, a Science Invents mission Vacuum. Vacuum is a proposal in the making and has been underway for nearly 2 decades to reach this day, but it is an endeavor to open the frontier of space, and to do so in the only way that can be, and that is to take it step by step and opportunity and challenge by each such step. We have a problem, Houston, with the rising quantity of debris in the lower to near-Earth orbital zone surrounding our planet. There are thousands and about to be tens, if not hundreds of thousands, of pieces of space junk that have been left behind in the missions over the past 70, 80 years. And it is imperative, my friends, that this challenge be addressed and in an increasingly urgent way. We are confronted with the possibility of being encased in our planet's sphere, around the sphere, if we do not act in time.
I can't see you anymore. Do it now.
Ladies and gentlemen, that brings an extraordinary sense of urgency to this mission, with thousands of new missions being lofted over the next 24 to 36 months. Tens of thousands of objects are going to be released into near-Earth orbital and low-Earth orbital space. That's a very serious change of affairs on a very asymptotic path, and this particular mission is the world's first global space mission, in the sense that every single spacefaring nation, every single spacefaring company or agency is going to have to grapple with this, and it's got to be a systematic answer to open pathways for going out and coming back safely from Earth. If we don't do it swiftly enough, we may be trapped inside our biosphere for forever, and that means we're only an asteroid hit away from you-know-what. And so we bring an extraordinary sense of urgency to this vital mission, and it is a pleasure and an honor to serve those institutions that would like to join this endeavor. And we expect a robust support from the United States government through the National Space Council, and though extensive discussions remain in that part of the ecosystem here, they're well underway, and we invite you to engage. But it is also a remarkable opportunity, because it has forced, by necessity, as its mother, invention. And invent we have. It is a pleasure to introduce Vacuum in that light. Let us leave no dust behind. Now, first, a bit of the history behind Science Invents and the National Working Group on New Physics. Approximately 25 years ago, I was then, in '98, chairman and CEO of US Web, which was the world's largest internet consultancy. We built the first or second websites and intranets for over half of the Fortune 100 worldwide through our offices in 10 nations. And by the end of '98, it was called US Web CKS, as we merged with our creative partner CKS Group. And it was an extraordinary enterprise of talented people worldwide. So, what would motivate Joseph Firmage to leave as CEO of US Web CKS in '98? Well, it turns out that I was actually in the 1980s inspired by the likes of Carl Sagan and others to go into physics as my first career choice. I was given an advanced entry scholarship to the University of Utah to study nuclear physics with the C.N. Yang Scholarship in, I believe, 1987. And leaping forward over a decade, by virtue of my position in the Valley and traveling around the world and such, I had the opportunity to meet a number of key scientists in the United States in particular, and my interest and fascination with my original topic of interest in my career was and now is nuclear physics. And I was astonished at some of the things that were being discovered and discerned, at least on the theoretical side at that time. Within 3 months, we had established 3 physics research institutes. One was led by Dr. Bernhard Heisch from Lockheed Martin that studied the theoretical interpretations or reinterpretations of gravitation and inertia from new perspectives. The second, led by Dr. Creon Levitt from NASA Ames, surveyed the world for the top 50 or so experiments alleging anomalous phenomena regarding gravity and or energy problems. The third, not largely known to either of the others, was the Los Gatos Material Sciences Laboratory, in which we conducted very specific tests on assertions and hypotheses about various types of metals in so-called super-deformed high-spin states. All 3 of these groups existed to survey approximately the top 50 of such experiments that had been invented by people all over the planet, and we either flew in or flew out to examine these things, and more than one handful, perhaps less than 2, proved very resistant to any prosaic explanation. By 2001, I'd put in about 20 million of my 33 million or so that I managed to make from US Web, and we accumulated everything together over those 2 years, and some astonishing observations were made, in particular about the nature of inertia and therefore gravity. Well, very much to do with precession. The nature of precession, a spinning top on a kitchen floor, is best characterized by the late and great Richard Feynman, and I paraphrase him. He described a spinning top on a kitchen floor as being very mysterious in the following sense. We know how much it wobbles around while the disk is spinning, but not how, really. Why? Not how much, but how. And they're weird, frankly, because they lean over in gravity while they're spinning, and they precess and then flop down. Why does the center of matter, notice I did not say mass, matter, which given equal axial endpoint lengths, why is the center of matter, which is always at the center of the disk, spinning or not, leaning over in gravity? That's a fundamental question that we were prepared to explore. And by 2001, in the first few months, a remarkable observation began to coalesce. And we believe, a very good, very, very good focal point on the nature of inertia and gravitation through the lens of how they interact together with and within matter through precession. Experimental program on ice for several years, and I returned to IT roots in preparation for this moment. And it's an absolutely incredible frontier of discovery and revelation of new kinds of technologies that rest and lie immediately ahead of us. It's a privilege to present this program to you today as Science Invent's first space mission, Vacuum. Let us leave no dust behind here, folks. Next slide. As I said, new physics is emerging and fast. It is my great privilege to work with scientists around the world in 60 or so nations. A few of them are some of my closest friends in life. I tend to have friends that are one or two generations or decades older than me, but it's an honor, in fact, to call people such as Dr. David Hessinus, retired physics professor from Arizona State University and winner of the Oersted Medal, which is effectively the Nobel Prize awarded to a teacher, a professor of physics. To be a professor of physics means you sort of have to know a lot about everything in every discipline of physics in order to earn that medal. And he is a dear friend of mine for the past 15 years or more. And you can read his quote here. It is a remarkable privilege to work with him as he explores the theoretical side of physics. Science Invent's experimental team is working on the empirical results from experimentation. Another example of some of the scientists who are involved in my life and this enterprise's leadership, Dr. Robert Carell, one of the probably top 5 climate scientists in the world. On one given month, this septuagenarian is frolicking with polar bears, literally helping to measure their viability. And the next week is at some NASA office somewhere in the nation or elsewhere in the world with another government, working on pragmatic solutions to one of the greatest challenges humanity will ever face and presently is in crisis to solve, and that is the climate crisis. I don't need to venture further in that area, but our back teeth are beginning to float, folks, and it's hot in here for our planet's life forms to thrive. Our work in Science Invents physics is very relevant to that topic, and it is also a pleasure for me to call Bob Carell a dear friend and trustee of Science Invents for a long time, and so many others that I could name, and forgive me for not, but let us move on. Now, the core is space debris and a comprehensive global systematic way of how we're going to clean up these thousands, now tens of thousands, and soon to be hundreds of thousands of pieces of basically leftover waste of metal and any other part you can imagine, and all the way up to full space stations that have run out of fuel, that have lived out their lifetime of service, and they're just basically slowly decaying and swirling around the planet. So you have thousands of meter squared type objects circling low to near Earth orbit between here and GPS satellites, effectively, and no way to get rid of them. They're traveling around, give or take, 15 to 25,000 miles an hour, and they can be as small as a speck of dust, literally a piece of sand, a speck of sand. Traveling at 20,000 miles an hour, that can depressurize an entire spacecraft and kill a living being. There are tens of thousands of space missions or objects to be deployed in space scheduled over the next 36 months. Tens of thousands. Ladies and gentlemen, that's an extraordinary concept to internalize. And that brings a sense of urgency and also a wonderful opportunity to focus the attention of aerospace in general on how to open the door for egress and ingress back to our planet. It is a doorway to our future, a doorway to the stars. Let's try to open it through a strategy like this. The propulsion engine that we have been seeking, we refer to as an inertial spin drive. And the details of this evolving experimental device are not going to be presented in this particular presentation, but are available for review under qualified non-disclosure understandings and agreements. In our case, at Science Invents, I represent a public-private partnership between government and industry at any and all scales that intersect our missions. But it's a private entity and will never go public and cannot be bought at any price. If my bet is correct, our work will touch everything that moves under power in the coming century. And it is a humbling experience, to say the least, to be a part of this, let alone to be its present leader. We're also a service organization, and we'll get to that later on, here to serve, not to command and control this project. And our propulsion system is at the core of it. Science Invents inertial spin drive is not a topic we're going to dive into in this particular session, but is presented under appropriate non-disclosure understandings and agreements. It forms the basis for the relevance of this proposal overall, as a matter of fact. We've been working for the past decade on these experiments, and let me give you an example of just a short one of how potent this can be. With a single 0.8 device, it weighed about 225 pounds, give or take, and was about 2.5 feet wide, 2.5 feet in depth, and about 3 feet tall. It was a cube, effectively, almost, of metal motors and appropriate batteries and such in a cube, almost a cube. And it's remarkable to believe, but it is a fact, that with about 110 watts of power into the box entire, that piece of machinery that weighs more than you, most of you anyway, weighs more than me, could exceed 1G up without expelling propellant, without anything coming out its butt, basically. It does require electricity, but an astonishingly small amount of it to power this machine. We'll talk a little bit more about that later, and a lot more about that behind the scenes. If you're interested in getting such a briefing and you're qualified, make an inquiry at contact@scienceinvents.org. The status of our experiment is best shown in the following slide. Here you see a very early draft. It's about 3 years old, on the left of what we refer to as acceleromotor, as contrast to accelerometer. Acceleromotor 1.0, or accelerometer 1. That is presently on track to commence a 120-day engineering build and assembly. We believe that by June, a device that will be roughly at 1 meter cube will be rolling off the assembly line and into testing laboratories. And it feels very good, my friends, to be able to say that. Again, I won't go into the details, but I will show you some of the incredible visualizations of our equations of action and principles of action that have in fact been rendered independently of, say, putting LEDs on spinning things. What we envision is nothing short of the world's first truly global space mission. Truly global in the sense that I mean it. Every nation that is spacefaring, every industrial company, even someday individuals who wish to have egress and ingress or go out and come back, must enter low Earth orbit, near Earth orbit, and beyond. They rest between land here and where GPS satellites co-rotate, co-revolve with the Earth's rotation in geosynchronous orbit. That space is where we're talking about, including those satellite perimeter zones. We envision the first global space clearance system. Clearance in the sense of creating pathways where we have recorded the perfected clearing of, like a tube or a tunnel, if you will, through space junk. Given the dynamics that we understand of gravitation so well, we have been able to track everything that is swirling around the Earth, as long as it meets a litmus test of about, say, a meter or so, and that will fall further all the way down to where it needs to be, which is very somewhere close between a millimeter and a centimeter, folks. There are thousands of meter square size objects. This is an actual rendition of from NASA, from NASA's own databases and its collaborators worldwide. Now, those paths don't just have to be straight up as radii from the Earth center out. Okay, those are very valuable, particularly for geosynchronous orbits, but they can be curved as well. As long as we keep a record of what's cleared and what's not, put some space boys along the way, these are our doorways to our future, in every sense of making Star Trek real. The border between science fiction and science future is getting very much narrower, my friends, and we do mean it. There's some big surprises to come in the year ahead. But in this type of command center, we envision international collaboration of the most serious order from every nation on Earth, every industrial giant, every person has to have clearance in both senses, a way through and the right to. And this must be part of the program logic that this international collaboration will be responsible for stewarding. And we will not, at Science Invents, be governing this system. Rather, we will be serving to help construct and operate it in those aspects of it in which we excel. In particular, propulsion, energy, and advanced materials. Those three areas we stand at your service, and we tender this proposal overview, while the in-depth proposal will be presented to members of the National Space Council roughly between January 15th and the subsequent 30 days. Consider this a table of contents overview. Now, there are many functions that this type of network command center, which will of course exist in many places, certainly on Earth and probably a couple on the moon and everywhere else we will travel as a result of advances in our space programs. Let's move to the next. So here are just 5 of innumerable major priorities for program operations under the vacuum mission. The vacuum mission, by the way, will be an emblem surrounded by many logos on the ships that you're about to see described in this presentation. Here are some of the 5 priorities for this mission. Okay, number 1, as I was implying just above, to interface with governance and governments, science, and the design, evolution, and R&D oversight. Okay, this program is a mission, and we are teeing it up and will fulfill roles within it. But there are basically a lot of logos on that rocket already before it's even made or designed and assembled and set up. Okay, for the first test. We have set the objective for this first step to be completed such that we can have a craft ready to launch within 1 year from this month to conduct tests in space of Accelerometer 1. We will return to the propulsion topic at the end of this presentation because we have a next step for those of you who really have caught the bug of this by now. We have a surprise for you at the end of this presentation, so hold your breath on our propulsion device. Now, the next point, we are driving towards the obvious unmet need. The primary goal is a global space clearance system, and as I said, clearance in both senses of the word. Now, the extraordinary nature of that phrase, again, bears some stress on a couple of other points. How will that be run? This leads me to point 3. The integrated command we propose and envision as being under the authority of existing and evolving military and civilian structures. We are not proposing in this presentation or otherwise that existing structures for command and control be altered fundamentally, but they do need to be augmented with functions that involve protocols of communication on a scale that the National Space Council of the United States, for example, was designed to, over time, engineer and to pioneer. But this must be an international effort and a public-private partnership of the broadest design possible. It also has to be highly secure for reasons that should be obvious. After all, we don't want people blowing up our trash machines, trash collection machines up in space. That would be a very serious problem. So there are all sorts of design parameters that go into this, and we want to work with the best for sure. Fourth, there are some GSCS specific challenges, some challenges that are specific and new that the space programs of great nations have not yet had the opportunity to confront. Let me give you an example. The type of propulsion that we are talking about here at Science Invents is called breakthrough because it meets 2 criteria. One, it leaves no dust behind. Okay? There is no propellant hypothesized to come out of our space propellers, if you will. Notice I did not say reactionless propulsion. I said propellantless propulsion. And we do believe we have a wake field, and it resembles more like a gravity wake field, or inertial waves is what we predict will be observable, but not matter. So, given the propulsion, what happens to the space program of the world? It goes from velocity to acceleration. Every rocket that you've ever known, including all the ones that are out there flying or about to, are designed based upon the idea you get a boost of thrust that gets you out of the gravity well of Earth, and then you enter low orbital space, near Earth or orbital space, and from then you start to float in velocity wherever you're pointed. You're going at a constant velocity, just simply floating towards your next destination point. And so you'll have bursts of acceleration and deceleration, but most of the time, which is why it takes a damn much time to get anywhere, is because you're going in velocity. What happens if you could go in acceleration continuously? I'll give you an example of that at the end of the presentation, of what it will feel like and look like and be like. But if you can get to the moon, say in, I don't know, maybe 5 minutes, to Mars in, say, 90 minutes or so, maybe to the nearest star a lot sooner than you have been taught. If there were certain mistakes in assessments of particle accelerator experiments a century ago, plus, we think that it is very much more plausible than you think that you might be able to visit a star sometime in your lifetime if you're 50 years or younger. My best guesstimate, folks, it would be within 20 years. We will be able to travel among stars and at faster than the speed of light, based on our experiments and our theory that matches it. Now, with that, things like communications latency become much more relevant. It's not a flat number like n picoseconds between one place and the other to communicate. As two objects accelerate together, that can be a very shortened period of time. And you deal with other communications, signal integrity matters as well. That's one of the priorities for R&D here. And another, and certainly last but not least, fail-safe control systems that protect the integrity of this entire infrastructure as foreseen to be able to have redundant algorithmic control and behavior of to control the behavior of carbon, us, and machines involved in transit and involved in the system itself. We have to be able to have fail-safe backstops for failure in emergency conditions because they will emerge, and not that infrequently. If you're talking about tens of thousands of people within 50 years, maybe hundreds of thousands, millions of people coming in and out of near-Earth orbital space on a given afternoon. Next slide. Next slide. We begin our discussion of the actual vehicles that will come in and out of space. The central part of the vacuum mission starts at the hub vehicle, which is envisioned as the hub of a hub and spoke system design that will be attachable or not at the mission choice to the International Space Station through standard docking procedures. We expect that and hope that the first mission will utilize conventional propulsion from ground to orbit, and provide the payroll containing a hub and 6 spokes, 2 copies of 3 different duty vehicles, also a double entendre, duty vehicles, cleaning up spaceship, basically, with spaceships. And so basically a hexagonal version, perhaps, of something like a Boeing craft imaged in the image to the right here. Boeing doesn't do everything perfectly, but no one or any company can. But I admire that enterprise immensely. And it is one of the enterprises we would like to discuss some options with in participation regarding the duty vehicles and the hub, as we do with most of the logos on the prior and coming screens. More on that later. But the hub and spoke design we envision would start for this test to launch hopefully within 1 year from this month of January. All factors considered, we believe we can. Would consist of a hexagonal-shaped hub craft that would be manned with up to, or at least enterable upon docking with ISS, to become manned and womaned by between 2 and 4 personnel to conduct operations of a hub vehicle, which we call Cyclone, affectionately, still in reference to the word vacuum. And that hub will perform the following duties: tasking and maintaining the duty vehicles while also uh, managing the flow through of materiel to the extent it is not destroyed or deposited somewhere outside of the hub. It would transit through this hub. But that, I believe, should be a rare scenario, for example, of picking up a person and not a piece of space junk, or a reactor core or something of value or threat that would need to go through it. That's pretty rare. It would be handled through that, mainly people, through the attach port for the hub. The duty vehicles would attach around the sides on a tightest packing function possible basis. For this test, we want a redundant pair of each of three classes of duty vehicles, and this hub will allow round-trip access for continuous supply and destruction and/or return to Earth in those rare cases. Next slide. Enter our Enterprise ships in the making, the duty vehicle classes of garbage trucks in space. Uh, yes, that's how it really needs to start. Let's clean up pathways. So there are three designs that we have in mind from an engineering and design point of view. These are classifications of ship design, the parameters for which obviously we forecast here, but will change as needs expand and evolve. The first type of class of ship, of duty vehicle, we refer to as sponge class. And with the affectionate name we propose for the first instance of it, Hoover. Hoover 1, for example, and Hoover 2 would be the two of this class. And a candidate I showed you in the prior slide is also here on the right. Well, this would be capable of opening up the package inside the duty vehicle, which would be about the size of an SUV, a large SUV. Um, that'll be on the next slide detail. But the package would be released through a through basically a hatch that's automated and deploy several meter to several tens of meters wide uh, frame with an aerogel or like material that gets progressively denser as it reaches a very hardened thin metal back frame, presumably, and could also employ electromagnetic either ion or other charge-based and magnetically interacting antenna to gather the small stuff that's smaller than a centimeter, and literally slow it down in a few inches of layered material, absorb it, and then wrap it up like basically a diaper. And then the disposal can take a number of forms. Let me give you two scenarios. One is wrap it up in a bundle and send it to a disposal site at, say, one of the many Lagrangians. Lagrangians are the natural equilibrium points between planets and moons and suns, where gravity is neutralized between the pull and push of gravity between two planetary bodies. And so those are ideal places to put trash and let it self-collect. Easy. It stays there without having to keep it too much propelled together because it does on its own. So let me introduce to you the first Class 0 member of the vacuum mission duty vehicle series of craft. It's the moon, our moon. Realize, please, that the moon has been doing us a big favor, life forms, all of us life forms, for many billions of years by sweeping out as a natural attractor space debris of the inorganic and non-man-made variety. That's the moon, folks. So imagine what we're talking about here over very, very long terms. The moon is the biggest protector of life on Earth. May she rock our tides for a long time to come. It's also a great place to have a command station for this program, in addition to several on Earth. So Sponge could also, and the others could also be disposing of material, or a depository at a Lagrangian could, every month or so, whatever, be sent into the sun, vaporize it safely by attaching a small acceleromotor to it, and just send it on its way. Okay, let it regenerate for another planet's future. The second class of duty vehicle is we refer to as net class, and that is, as it suggests, envisioned as a weaving of, say, carbon fiber that is semi-flexible and very hard to break. That would have perhaps a sponge behind it, in n meters wide, looking like a radio dish, or whatever shape is desired. But it would be deployable and expandable from the capsule of the second duty vehicle class, thus providing, say, a centimeter up to whatever size the net class vehicle could perform and carry. All three of these, or at least two of them, and possibly all three, are unmanned. Certainly the first two are envisioned to be unmanned vehicles, therefore thoroughly automated. In Class 2, like Class 3, which we refer to as Web, with the affectionate name, perhaps, Spider-Man, evokes the image of what Class 3 should be like in our appraisal. Throw out a web, with or without some propulsive units attached to it. Without them, just basically grab something like a three-dimensional lasso and into a net, like a fisherman would in the ocean. And that is capable of tackling things that are either modestly big, say a meter, to, you tell me, how about an asteroid? Particularly if you could guide parts of that web and wrap it around with small acceleromotors. P.S. We believe that it would be fairly straightforward to manufacture these propulsion engines as small as 1 cubic centimeter. Think about it. It's a matter of materials printing. Okay? So Hoover, Shopvac, and Spider-Man are proposed as craft names, and would like 2 of each on around this hub. The third may have a man or woman inside, perhaps, either recovering an astronaut, perhaps, through this system, or having one guide a specific mission that is mission critical, such as one I just mentioned. So now, on the next slide, let's peek inside a Sponge class vehicle called Hoover, or Hoover 1. Inside, you see 3 basic things visualized here. 3 main components are the propulsion engine, and this is comprised of a quad of engine blocks that would be approximately a meter cubed. Okay, a carbon fiber permanently sealed box, if you will. It's highly ruggedized, and it has only 2 ports, or 3 if you include remote control, which is an obvious necessity, but not always. But you have basically data and electricity for charging purposes only, in and out. Data, power, and control to the extent that it is not supplied through data. So you've got those 2 or 3, and only those 3 interfaces with the outside world of the propulsion system. Inside it looks like an inertial drone, so to speak. More on that later. Whose only wake, therefore, as I suggested, is limited to, at most, gravity waves. The package, or payload, is the distinction between the three duty vehicle classes: the sponge, the net, or the web. That is the second. The third component is not shown here, but is implied, and that is basically the batteries. The wonderful thing about the propulsion engine parameters that we have defined for this project is that we will be able to actually test multiple breakthrough propulsion engines, not just our own, in this mission program. Vacuum will be able to test the best of breakthrough propulsion technologies in the world, and we will invite again those potential partners and associates who would like to inform us or to engage in conversations strategically and tactically should go through contact@scienceinvents.org. In our case, we have a very specific design that's rather exhaustively tested for the purposes we were talking about. Just imagine an inertial drone propeller that sends out its payload, does its job, and is fully unmanned and automated with the hub control managing operations at that level. And then the batteries around about are basically responsible solely for providing electrical current. How much? Now we get to one of the most interesting and controversial questions about this kind of propulsion. Don't you need a Jupiter where the moon is, Joe, to provide enough gravitational pull to do something useful? No. There is a very wide and widening gap between presumptions about how gravity functions, and I happen to be of a rising minority opinion, comprised of the engineering-minded physicists out there, that gravity is not a dimensional warp, but rather an asymmetry or an equilibrium a condition of a momentum flux that pervades the cosmic quantum vacuum. You might consider it like dark energy. My mental picture of it is, as I named it, potential momentum, or potentum. That, I believe, is what we refer to when we talk about space, and it sure ain't a void. So what we're talking about here, therefore, is a novel insight into this Newtonian mechanics. What if the F equals ma that we all know and love, grew up with, were to have hidden inside of it for all these centuries an unrealized and very specific geometry of action that would define not just the relationship between force, mass, and acceleration, but define their geometrical dimensional identity. What does it look like? What does the equation look like to render? How does an F create an A out of M? What is M? Really? What is A? What is F? We have answers to those questions that are extremely intriguing. Let me give you a hint. Imagine there's a fire burning in a New York apartment tower, say 6 stories up. Fire truck arrives, and you got to shoot a stream of water 6 stories up. Takes several husky firefighters to take that hose, say 12 inches thick or whatever, and pump thousands of gallons of water, 60 feet up per minute. You try to change that water flow by standing in front of it. Good luck. Your head will be gone before you can think the thought to move. So how do we analogize this to what we're talking about? Sideways. We believe we know how to alter the momentum flux that we would otherwise call ambient gravity or inertial momentum as the momentum flux from the side, using rules of chirality in defining the very nature of inertia itself, and therefore mass. What if we can control and separate the center of mass from the center of matter that possesses that property? What if we can separate the center of mass from the center of matter? Ladies and gentlemen, what if that's what a spinning top on a kitchen floor is doing while it's spinning? Note that simple analogy. Spin up a top when you get off this presentation, okay? Show your kids, too, while you're doing it. And look yourself at the procession as it wobbles. The late and very great Richard Feynman, one of my real heroes in science and life, described and characterized procession as largely unknown. Not as to how much it wobbles around, how long in relation to the spin of matter and its content, but how does it work? Not how much, how. Why does it lean over in gravity when it's spinning? The center of matter is off axis to the vertical, folks. Where's the center of matter in the spinning jar top on your kitchen floor while it's spinning? It's off axis, leaning over. How does it do that? Just because it's spinning. Because the center of matter is the same, averaged out. But the center of mass, which is this place where reaction occurs in mechanics, a resistance is moved from the center of matter and separated to the tip point on the kitchen floor. Do a time lapse when you have time. Open the shutter of a digital SLR or your iPhone and keep it open for a minute and film a spinning top. Looks like an Aerospace dish pointed down the kitchen floor. And it's trying to fall towards its center of mass reaction. That's how fun this propulsion system is, and why it requires perhaps very little electricity to power a lot of thrust. And the central principle of action, we believe, will turn out to be the conversion of angular momentum into linear momentum, or thrust, and vice versa. The vice versa would be for electricity generation, or regenerative inertial braking. That's another conference presentation. Next slide. One of the central questions that this particular mission uniquely raises is, given the combination of the potential for breakthrough propulsion here as one of the foundational aspects of the ability to successfully execute this global space mission over time, involves the rate of clearance by the class of duty craft. How much volume of pathway can be cleared per unit time? Those are fairly easy equations to work out. They involve the reach of each of the three classes of duty craft for the area that is either swept through, vacuumed up, or netted or webbed per unit of time, including of the factors that involve acceleration as an available asset. In other words, the ability to literally turn on a dime and reverse course, and to put it simply, the answer to the question is, how fast can you put two duty vehicles to work at opposite sides of, say, a sphere or a disk with a thickness perpendicular? The thickness of the disk it would be longitudinally in the direction of the pathway to be cleared. So you have an area, the area of a circle, okay, with a depth of with a radius of the particular duty craft's reach, regardless of the craft. There's a defined range of reach for the mode and the payload package. Say the size of that, the size of the web, the size of the sponge, and the amount of time. So you got the integral of the period, the integral of the period times the area, and then a tightest packing function for the designated programmed volume in total to be cleared by the tightest packing function, including turning around and say a sphere. So if, as one of my national security advisors and colleagues has indicated, one of the central challenges as a priority is the geosynchronous outer sphere, if you will, around Earth. That geosynchronous orbital layer for neutral orbits, effectively, and intentionally paraboloidal orbits or other shapes that are non-circular, okay, and can be highly shall we say, paraboloidal, orbitally speaking, including under power, intentionally for repositioning satellites in relative geosync. That's a perfect example of why, if you want to clear out 100-meter radius surrounding any repositionable or stationary satellite, that is a very taskable objective for any of these three classes of duty vehicle. And the calculations and programming for such, with a tightest packing function of that snake, if you will, wrapped around and around and around and around itself for a circular volume with a 100-meter radius, is a very straightforward calculation when you know what kind of rate of acceleration is possible, given the classification of the propulsion engine itself. That's the driving factor, quite literally. The engine room, Scotty. I need warp factor 1. I need X acceleration to a velocity, certain velocity, relative to the desired frame of reference of motion. Pronto, or we have a problem or an opportunity. Next slide. Major priority for any space mission, any build of anything sophisticated these days, of course, is testing. And this one must meet extremely high standards. Here are the top 11 in general terms. And those of you inside this industry know what these mean. And I'm not going to go into the details, but generally speaking, we aim to be able to commence testing of this system on ground by approximately 11 years ago. As for the first deployable version, about 150 days from now, our strategic industry and government partners will be receiving the first acceleromotor ones for Earth-based testing sometime, hopefully within 4 to 5 months. They're to be made rugged for and appropriately refined for space deployment. And thus, we could see testing on system components for 1.0 starting within 4 months. In parallel to that, obviously, testing on system components has already been underway. Specifically, for the vacuum mission, it's been underway, called Project Hoover, for over a year already. So we're well into the 1.0 period here. And our objective is to see an appropriately labeled rocket on a conventional pad, but with an unconventional payload, able to launch within 12 months. Let's try to pull that together, folks, because I believe we sure can. Most of the components in this entire presentation are available off the shelf from Lockheed Martin or SpaceX for not the price of a piece of toilet paper, but it'll do a great job for a few $1,000,000 to reuse hardware that is already being deployed productively for other space missions. Propulsion, energy, and advanced materials are the three components where real innovation is present. And we exist at Science Advance to serve you jointly for this and other missions ahead. The Vacuum Mission Alliance represents a profound opportunity for a kind of coalition of the adventurous, the excited, not just the willing, but the necessary as well. For entry and return to outbound to near Earth orbit and beyond, this is a must-have for any spacefaring nation, company, or agency in the world. Over time, I would expect that a duty vehicle would be required cargo as part of the payload of anything that goes up into or into low to near Earth orbital space, let alone beyond, of course. I would expect the Class 1 duty vehicle to be a part of the payload within 5 years of every launch that there is. And Class 3, a net or web, to be required on every ship that goes beyond near Earth orbital space, certainly if it goes beyond a geosynchronous status. And if it's not geosynchronous, if it's not at least synchronous with the orbital velocity of the circumferential tangent of MV of a particular particle stream, it's not in the stream. And the more it's out of the slipstream of particulate flow, matter flow, that represents the de facto equilibrium point between centripetal and centrifugal forces related to gravitation and inertia. That equivalence point is a slipstream, and it represents the ideal pathway, aka a spiraling pathway outward trailing. Is the most convenient one to start at acceleration, relatively speaking, 0, which would mean velocity constant for a given radii, given by well-known equations, of course. Now, the logos represented here are a mere fraction of what are required, but they represent obvious choices that we would propose be among the first responders to our call for a conference that would be conducted no later than June of this calendar year, June of 2020. And details about that will be provided later. As a preliminary to that, we are proposing that the working group nominated leaders of 15 working groups that have been posted into this network on LinkedIn already, approximately 15 working group members, particularly candidates for leadership of such working groups, we hope will convene and join us in Salt Lake City, Utah, and or Phoenix, Arizona, and Washington, D.C. for a 3-site simultaneous 2-day conference that will be virtually connected in the month of April of this year, as a preparation for a June, at the latest July, conference for the planning of the first stage of this mission. Again, contact at scienceinvents.org is a good way to start. I've been associated in several ways with, not working for, but with our government for 3 decades, nearly. My first $1 million license of software for my first company, Sirius, Serius, aptly named. It's time to get serious about going to Sirius, and take a look at its logo. If you have an old box, that one laying around before it was bought by Novell, and I renamed it Appware. That's how long ago I started working with the incredible men and women of our armed forces and intelligence communities, and have been associated ever since, not on a paid basis except through our companies, work products and services, and I have a lot of friends there, including Dr. Ron Pandolfi. We are good friends for about 20 years, and he is a physicist and mathematician of the highest order, and is also a colleague. And this quote represents the government's stance with respect to vacuum mission, and it speaks for itself. And it is an honor to be able to work with him and many others at that level. So, next slide, please. For those who choose to be a part of the planning stage of the vacuum mission, as part of this alliance, both the physics and the vacuum mission timeline teams and timelines are available in a Gantt chart project management interface in some detail that stretches out over the next 5 years, but kicks off beginning with the conferences that I'm going to describe in just a moment. We are very excited to literally be kicking off formally this mission beginning on January 29th, 2020. Now, finally, I'd like to describe where Science Invents is at, how it's structured briefly, and what we're requesting of potential alliance partners. Both government and industry leaders do need to connect with us as soon as possible. Science Invents is a public-private alliance partnership with net revenue royalties as the liquidity model for existing and pending and future capital partners on the industry side. Our focus is on breakthrough propulsion, energy generation and storage, and advanced materials with a fabric of advanced IT or AI, a multi-cortex AI platform that Many One represents to help run our information systems and very sophisticated access control systems for this kind of project to thrive, with potentially hundreds of thousands, possibly even millions of people over the next few decades involved in it. We are interconnected with roughly 7,000 plus leading experts externally employed across 60 nations and other companies and agencies and institutions. This community has been integrating for 20 years and took a big leap forward when this LinkedIn network began to interconnect exactly 1 year ago this month. And that's for future discussions as to history books, but suffice to say, we have the A-team and all of you. Next, our revenue is comprised, for your information, principally of IP licensing. We wish to be working with you as a service provider and an IP provider. under license and engagement. That is where our revenue comes from and where it will stay. Finally, we have roughly $2.5 billion in obligated future liquidity to accomplish 100% liquidation of private equity interests, private sector capital in general, debt, and all labor. That is exclusive of our needs from this point forward, which I will summarize in a moment. But that's a short summary of our structure, how we work, and how everybody gets paid. So the first 10 members of the alliance that we jointly choose against each other will have seats at the table for joining this program, this mission. They will receive an accelerometer 1 unit for internal testing and also receive limited licenses, subject to further negotiation, for the incorporation and deployment of our intellectual property, our patents, and our and both present and forthcoming surprising extensions of this discovery and the innovations related to it for their own space missions, for their own products and services. And that will obviously include, over time, not just space missions, but automobiles, planes, basically anything that moves under power. And so we are very excited about the opportunity to work with 10 lead aerospace related leaders. You know who you are. If you're watching this, you know who you are, and we really need you to join this effort. Let's fund it together. Let's make it happen together and share the benefits within our enterprises and with the world desperately in need of this system. My friends, colleagues, ladies and gentlemen, this is a once in a planet's history process. It is remarkable to think about it in those terms, and as a result of the nature of this mission, it is global in nature. It is an ecosystem by necessity, and thus has to be by design. We need you. You are needed now. Our structure is such that we have 10 of 15 permanent seats open. The existing 5 are related to governance and government. Remember, we are here to serve you, not to govern. So this is a round table. And we would like the 10 most responsive parties here. If your logo was there, you're needed, wanted, and welcome, ASAP. The first 2-hour session will be January 29th at 1 Mountain Standard Time, 1 p.m. MT. video conference, and it will be followed up by another 2-hour video conference the next day, Saturday, the 30th. This will be a planning conference strictly for structure and laying out the Gantt chart in detail and making major adjustments and then minor ones on the following day. And part of that agenda will include planning the first in-person conference to be held at 3 linked sites on April 3rd and 4th, 2020 in Washington, D.C., Salt Lake City, and Phoenix, where we have and or will have significant operations by that date, long before actually. In conclusion, at Astra, colleagues, let's launch this a year from this month. Let us turn science fiction into science future. In fact, starting this month and launching a year from now. Join us at Astra. This has been a presentation of Science Invents, Missions That Matter. Thank you.